Hello, everyone. Welcome to the second session of .NET July and in Microsoft Zero to Hero community. We are part of Microsoft Learn, a community that tries to connect learners and experts with each other to build up a better community, a more knowledgeable one with you guys. As always, be patient, be respectful to each other, hear each other's opinions first. Maybe there is something to think about. I am Shahab, the guy who happened to be a software engineer. I will be the host for tonight's show. And I hope you're having a great time wherever you are on this blue planet, whether it's morning or evening, watching the stream live or recorded. I vividly remember the first time I hit the billion-dollar mistake, null reference exception, and it was during a presentation at my university in front of all my classmates, and it was embarrassing to see my application crashed because I didn't know why. And hopefully tonight we have a C# expert and a Microsoft MVP who could tell everything about nothing in .NET. And I'm happy to invite Stefan, without further ado, to tell us more about null and void on the stage. Hi, Stefan. Thanks for accepting and being with us.
Hello, Wold, and hello, Shahab. It's always a pleasure to see you. Thanks for the invitation.
Yeah, our pleasure. Thank you for being with us. And I hope everyone enjoys learning more about null and void. I have a lot of questions. Hopefully they will be answered during the session. No pressure. By the way, we still have a voucher for Microsoft exams, whether it's fundamental or advanced. It's a 50% discount. Fortunately, Stefan, you have to choose the winner because, and it goes to the best question you choose. So no pressure at all. Okay, great. Then the stage is yours. And let's have a great evening together and learn about null and void, everything about nothing in
.NET. Thank you so much for the introduction, and hello, Wold. Thank you very much for joining me either live or on the recording. My name is Stefan Pölz. I am a Microsoft MVP. I just got refreshed for another year the other day. I'm also a JetBrains community contributor. I am an engineer at Sentry, where we will help you to find problems in your applications quicker and more precisely. I'm also a co-host of the .NET meetup in Vienna. We do have our next session almost announced. I'm also a co-host of the To Code or Not to Code live stream that I'm hosting with a friend of mine. We will delve into benchmarking in the next episodes. And if there is anything that I cannot answer live, or if you're watching the recording, would like to reach out to me because you have any questions about null and nullable reference types, then you may reach out to me under any of these social medias. I'm posting in the chat the link to this. Oops, that's actually the wrong link, right? I should be showing. Oh, that's semi-embarrassing. This one. This is my socials. Perhaps Shahab, if you could share this link in the chat.
Drop them in the chat. I will post them on the screen.
Thank you. If there is any questions I can't answer live or the recording. And now it's time to jump into null and void, into nullable reference types, a feature that got introduced in C#8. So nullable reference type haven't been around for the better part of C#. But we also take a look at what void is and also the sibling nullable value types. And there is a significant difference between nullable value types and nullable reference types, or NRTs, how the cool kids are calling them. All right, let's jump into the code. Let's take a look at what a nullable value type is. Let's start with a regular value type. Creating an integer, value is 1 to 3, and I'm just printing the value to the console. Let's see if we get these strings and also the 1, 2, 3. Oops, I just launched the wrong application. Console app, there we go. And we should see 3 lines of code. There we go. Now, what about nullable value types? I can add a question mark in front of this integer. Now, an integer or the int keyword, if we take a look at the actual declaration in the BCL, the base class library, we see it's in the system namespace, and it's a struct. So struct, types of kind struct, are value types. They really hold the value themselves. The other part is a class, a reference type, so where the variable is just pointing to the actual value. So in here we do have the actual value, but how can we make an actual value now nullable? Well, actually we can't. A value type, since a value type is really, let's say this is my memory, now the value type, this int 32, so that's a 4-byte integer, is really held in memory. Only reference types can be null, because let's say I have here nullable reference types. If I were to make this a string, now this is a nullable, this is a reference type, and this is actually pointing, the value here doesn't really have the string itself, it's just pointing to an address where the value lies in memory. And this pointer may be null. But if I'm switching back to the value type, that's the value directly. I can't have just null in the memory. This is not how it works. So how they work around that, there actually is no int question mark. What happens under the hood, if we compile that and take a peek at the lower level C# view, for what this tool is doing here, it's basically compiling our C# code to IL code and then decompiling it back to C# code. So we get all of the syntactic sugar that the C# compiler or Waslin has in store for us. And I guess, okay, compiler does a couple of optimizations, so we didn't see what's actually going on. So let's add an if check. Because what we can do with a nullable value type, we can check if it has a value. But where's this coming from? If I'm doing this question mark array, int doesn't have an has value property, but the int question mark has. And what we see there, that by adding a question mark, we turn this into a totally different type. This is no longer an int. This is now a nullable of int. And I hope that we can show this in just a second. And when we take, it appears that the ReSharper compiler is very smart and optimizes it heavily for maximum readability. But if I go into the actual IL view, we see that this value is not an int, it's the system nullable of backtick1. Whenever you use using backtick1, this is basically in C#, it's represented by the generics. So this is a nullable of generic T. So what happens is we actually have now a nullable of int. So when we write int question mark, we get a totally different type. And this type now has the has value property, and it has the value property. Now the thing is, if we access the property, let's say I say value dot value, if we access the value property without checking, now this doesn't throw the nullable reference, a nullable reference exception, the billion-dollar mistake that Shahab has mentioned. It's actually throwing an invalid operation exception, because it's just a value type. A value type cannot be null. It's just syntactic sugar, where we see if there is no value set, then we throw an invalid operation exception. If the value is set, we do return the value. Hence, we should check for has value first. And this is what the compiler is also hinting at me. We get a warning saying, yeah, possible invalid operation exception, because I did this the wrong way around. I should then, within the if check, first check, does this nullable int have a value? And if not, then don't dereference or don't access the value field, because it will throw. And instead, we can now throw, well, had no value. And we see go into the, had no value case. All right, so when we add a question mark to a value type, we get a totally different type. What about nullable reference types? Let's say we have a string, and well, let's not make it nullable for now. Let's call it text, and I assign null to it. Now, I would like to print the length of the string to the console. We already get a warning here, the compiler, and the tooling is giving me a hint. Something may go wrong and something will go wrong because now time has come for the billion-dollar mistake. We now get the system, the null reference exception. Because a string, if we jump into the declaration, that's a class, and a class is a reference type. So this text now is referencing, well, it actually has the null reference. And if we try to, when we do dot, we would actually then try to dereference this value to where it actually stored and then inspect the properties of it. But since this pointer is null, when we try to dereference it here, we get the null reference exception. The compiler is already giving me a warning. This warning didn't exist before C#8. Now, if I actually add a question mark, I get another warning because I didn't enable nullable annotations. We can use nullable reference types only in a nullable annotation context. That means nullable reference types, or NRTs for short, they really are an opt-in feature. Per default, there is no nullable reference types. Because, yeah, they were introduced in C#8, so at the time where nullable reference types were introduced, the most part of the code were just not null aware, or in other words, was null oblivious, because we didn't have the feature just yet. Now that we have the feature, if they would flip it just on by default, now you update the compiler and you get warnings all over the place. And if you have warnings and errors, you couldn't build your apps anymore. So because this could be some quite intrusive to existing code bases, depending on the size, this really is an opt-in feature. Now, if I go to the C# project of my example here, what I did is nullable disable. That's the same as if I didn't have this MS-build property at all. When you do on the command line a .NET new, and let's say a new console app, what you get these days, so with every new application, they are part of the template, you get nullable enable. And this feature is now enabling this nullable context that the compiler was complaining earlier for the entire project. So every document, every C# or Visual Basic file. Is it Visual? No, actually, it doesn't support Visual Basic. But F# now also supports it as well, in F#13, I suppose. But in C#, we need at least C#8. If we were to change the language version to, let's say, 7.3, we will get, again, some problems in our code. But with 8 and above, we can now enable nullable reference types for the entire project. And every new application, all the templates now have this enabled per default. And when we do, we no longer get the warning here when we add the question mark now to string. The thing is, the difference between nullable reference types and value types, if we do a question mark on a nullable value type, we really get a new type, namely the nullable of T. If we do this on a nullable reference types, there is no different type. Nullable reference type is just a compiler annotation. This doesn't have any one-time impact. It's still the same string type. We will take a look at the metadata or the IL code later. Under the hood, the compiler will emit some attributes, but they don't have any one-time impact. We still potentially can have nullable reference types, null reference exceptions at runtime. It's just a compile, just under air quotes. It's a huge feature, but it's only at compile time, and we will get warnings and potentially errors if we configured warnings that way, if we make violations for these nullable contracts. Now, since I declared this as nullable, I'm allowed to assign null to it. If we were to declare this text here as non-nullable, we get a warning already assignment because we are converting the null literal to a non-nullable type. We didn't annotate this text of type string with the question mark. It's non-nullable. So assigning something that is potentially null doesn't work. And that also works in a chain. Let's say I have another string, other string. And if this other string, let's say, is nullable, I can't assign this nullable string to a non-nullable string. The other way around, however, is fine. If I were to assign a non-nullable string, if I were to assign a non-nullable string to a nullable string, well, that's fine because it's annotated as nullable. It's either null or not null. When we have a non-nullable string, it's definitely not null. So this way we are not violating the contract. But if we are assigning something null to something that we said it shouldn't be null, we get warnings. But again, they're only at one time, at compile time, not at runtime. So if we were to do the null here, we do get a warning here, dereference of a possibly null reference. And if we run this, we dereference the string. There is no length on null, so we get the null reference exception. And what I should do is build a null check around it and say if text is null, is not null, better to say, only then dereference it. And otherwise, let's say text was null. Now we don't have any warnings anymore. Compiler is happy and our runtime is happy as well because we don't run into any null reference exception anymore. But again, just a compiler feature, nothing specially going on at runtime. Now we can
May I ask a question myself? What, is there any if I say if text is not null or if text not equal to null?
Ooh, let's like so.
Yeah.
With a string, no.
Okay.
String is the only reference type where there is no difference if you say is not null or if you say is not null. Because the compiler is very well aware of string or system.string if we not were to use the C# keyword, but the BCL type. The compiler, Roslyn, is very well aware of that and actually does here also a pure null check. Now, actually, I plan to go into what a null check is earlier, but it's an excellent segue. So I prepared a test for that. Now, if I run all of my tests, I got one failing test. Let's jump to this test. And this test is actually, doing something with equality. I mean, let's get rid of everything that we don't need. So we just have here, we initialize a new class. There is an instance of this class. It's not nullable. Well, I could declare it as null, but it's a non-nullable class. If I were to assign null to it, we get can't convert the null literal to a non-nullable type. So there isn't anything null. And then I do a null check. But I do run into an exception. Well, I have some not implemented exception. So this now shows that, excuse me, my tooling is...
Don't worry.
Am I back? No.
Okay. In the meantime, if you guys have not already subscribed to other sessions, you could go to bit.ly/.net-2025 for the next sessions to be informed about that.
So my Zoom is back. Yeah, I can't do anything without those arrows anymore. That's insane. Well, at least on Windows. On Mac, I'm now exploring some tools you showed me, but I'm quite not as fluent with them. Anyway, I digress. So we see that this here, if this was a string, actually let's convert this into a string. Now we see that this is, I have the same color as for this is a white inequality operator. If I change this now to my class, this gets a different color. This indicates that this inequality operator is overloaded. So if I jump into the class, here is the perpetrator. I did implement all the equality. I made this class equatable. I implemented I had the bool, the object-based equal, the one from the equality, also overloading the equality operators, and we run into this not equal operator. And we see this is the not implemented exception that we get. So where's the example? This, if the operator is overloaded, is not a pure null check. This is actually invoking now this inequality operator. And I better, well, all types of the BCL implement it correctly. And I guess 99% of the types of the ecosystem implement it correctly. But you could make a mistake, and then but technically speaking, it's more than a null check, because we invoke the operator. Well, the runtime is pretty smart. There is a lot of inlining going on, so this is not really a performance price that we pay, but more stuff is going on than just a null check. If I were to say is not null, that's a pure null check. Now let me show that to you. I hope that IL code isn't optimizing it away. So we actually see that here in this line. I'm not jumping again to IL code. So that's the intermediate language code that all of the .NET languages, C#, Visual Basic, F#, and custom languages, custom CLR languages, all compile to. And the .NET runtime is aware of how intermediate language works.
Yeah.
And when we take a look at what actually happens here, is we see that we call this operator.
Yeah.
So this is not a pure null check. Now, if I were to change this to the is not null and recompile, what we see now is, okay, actually the compiler is optimizing it away because it's not doing anything. I was hoping to show. Let's jump to, I actually can't show this with a string, because actually string does overload the equality operator, but we still get the right one because the compiler is aware of it. And when you do string comparison, it's still a pure null check because the compiler is aware of it. But any other type, let's say a stream, but stream doesn't overload the operator. Let me just briefly, let's do a record. Record.
I hope I have not diverged the talk.
No. That's a good. I love this. I love this example. What a record type really is, we get all of the equality operators that are shown earlier on class implemented automatically, and we say that this equality operator now is turning in this color again. And again, we should see in IL code, we call the inequality operator of record. If I were to change this, it is not null. We compile, take a look at IL, we see that now we do get a null check. We load null, and then, well, I can't really load a read IL, but we don't see any invocation of any member here.
Yeah.
So this is a pure null check. Alternatively, what you could do, because this is a newer feature, I think that C# 9 or 10 didn't exist forever. Previously, if you wanted to get a pure null check, what you would do, we see that's the purple equality. You would upcast the class to object, and now we get the equality operator from object, which is a pure null check.
Yeah, I see.
And this actually, I did prepare a couple of I did prepare a benchmark for that. So we do see, well, this is sub nanoseconds. You will not have performance problems, but it just shows the difference between, for example, if I invoke, oops, that's the, I want to show this one, yeah. I'm having a record type. So if I invoke not the inequality operator on record type, it's something nanoseconds, yeah.
Yeah.
And if I do for example, the is not null check, or any other that is a pure null check, like something like this, it's immeasurable. Well, we're definitely sub nanoseconds. So these, from performance perspective, this has not any impact. And with modern JIT compilers, this will definitely have no impact at all, no measurable impact. But still, it shows the difference between a pure null check and actually calling methods, calling operators.
Great, thank you.
Sure. And yeah, so now we know what a pure null check is and how null checks are performed. So let's take a look into how this nullable context actually works. So where's this question mark coming from? I previously said in my project, sorry, that's the wrong project. Here we go. Nullable enable. What we can also do is we can set this to warnings. We can set this to annotations, and we can set this to disable. So we have 4 states here. Our nullable context is either enabled, disabled, annotations, or warnings. Enabled is a shortcut for both annotations and warnings. Annotations means we can place question marks. Warnings means we get warning when we try to dereference something that was annotated with a question mark. So it's kind of a producer-consumer thing. We need, if we want to consume nullable reference types, we need a producer that is placing those types. For example, the BCL. When C#8 came out, not everything from the entire ecosystem was annotated because this feature just got released. It took years for the entire ecosystem, for the base class library and for NuGet packages to adopt all of the methods and all of the properties with the question marks, or not question marks, depending on the actual nullability. So those are the annotations. And then all the consuming projects, like all of our applications, now will get warnings if we try to dereference something that may be null. For example, I'm now trying to call something here on this instance, and since it may be null, we get a possible null reference. And we can control this, this context. This is only on a project level. I will enable both warnings and annotations on a project level, but we can also control them on a file level. So I could say with the preprocessor directive, nullable, we get the same things again. We have disable and enable. And when we say enable, enable just enables both warnings and annotations, but we can also say just enable annotations or just enable warnings. Now, let's disable the feature. And if I were to declare a class, my class that has a string text property, and we see our constructor doesn't set it initially. So if we were to create a new instance of this new class and were to access from the instance.text.length, we will run again in the null reference exception because we try to dereference text here, which was not set to anything. Our constructor is not initializing it. Now let's enable only annotations. Nullable enable, but only the annotations. Now with annotations enabled, we can place question marks. If we don't enable the annotations and I place a question mark here, we get a warning because we are not in, we don't have nullable annotations enabled. So the compiler is not producing the annotations. Only when we have nullable annotations enabled, now we can place question marks. We actually get a warning here because this type, the constructor, does not initialize the not nullable text property. So after the constructor is called, text will be null, although we have not annotated it. So it's not nullable. Therefore, now we need to place a question mark here. Let's say we have a non-nullable text, but also a nullable text. Now I will annotate the nullable text with question mark and definitely assign the nullable text to something. Well, I will just say empty string, but empty string is a valid reference. It's just empty, but we actually have an object. There is no null, so everything is cool. Now we can say if we try to dereference the non-nullable length, everything is good. We should, well, let's actually put some text. Hello. So we will get the string of 5 printed to the console because the length of hello is 5. But if we were to do the same thing with the non-nullable string, we will get null reference exception. Now, Wider is quite smart, and although I don't have nullable warnings enabled, Wider is still warning me about this. Now, this depends on the tool. If I were to do a .NET build on this, I wouldn't get any warning, but still have the runtime problem. And for that, we would need to enable the warnings. Now, only with these enabled, now every tool, or the Boston compiler now shows a warning here because we are dereferencing something here that may be null. Not necessarily is, because I could set it to something, but it still may be null. But the compiler doesn't do a dynamic flow analysis, only static flow analysis. We dereference something that is potentially null, and therefore we get a warning. And we can control, so if you have a new project and if you want to step-by-step adopt nullable annotations, you can do this with these annotations or with this prerequisite directive step by step. You could say, hey, I'm producing for my existing types, I'm producing warnings. And for the consuming part, I will be, oh, actually the other way around, sorry. For the producing part, we could enable annotations. And for the consuming part, we could enable warnings and then step by step opt in until you have annotations everywhere. And if everything is annotated and everything has warnings enabled, then basically what we could do then is get rid of all of the preprocessor directives and just set it on a project level. And then we have nullable reference types fully adopted.
So if I understood it correctly, when I have nullable enable for warnings, .NET Build will also show me those warnings, and like I will have them in the output when I'm running. But if I don't have it enabled, it will just ignore it. It just depends whether my tooling, like the IDEs that I'm using, are acting or not, and just giving me a hint about it, right?
Exactly. So I will now disable warnings. That means, so these annotations, they go from top to bottom. I have enabled both warnings and annotations on the project level. So here we have both of them enabled. Then I disable only the warnings here. Now, Wider kind of ignores that. So Wider shows me a warning. But if I do now a console, open in terminal, and let's do a .NET build on that project, we get some, I've enabled all of the analyzers, so it's mentioning that something could be sealed. It's protecting about, actually I'm wondering, because I have some other warnings, actually. Ooh, is it showing? I'm surprised. I was not expecting any warnings, but we did get some, but I guess it depends on the tool, maybe.
Yeah.
Kind of shouldn't, because it disabled the warnings, but we still got them. I guess it depends on the tool.
All good. Thank you.
Wonderful. And yeah, we could enable and disable them just as we like. And now let's take a look at how this really is happening under the hood. What does the compiler make out of all of these nullable annotations? Because it has been a feature that was added. Previous language versions didn't have it. So how does this really work? Let's take a peek at this type here, where we have a method that takes a string parameter that is annotated with question mark. When it comes to nullable annotations, we will see now a lot of attributes, because this is really what's happening under the hood. The compiler will add here an invisible attribute that says that this string was annotated with null. It kind of will add more or less an invisible attribute here and saying that this string was not annotated with null. And in a more advanced scenario, if we, for example, I'm now having a part, here we have nullable enable, but then for this portion, we disable nullable annotations. That's the same as with any project that was pre-existing C#8, or when we have the feature disabled, we actually here don't know. This is now oblivious because, well, we can't annotate it. We get a warning when we do annotate it because we are in a non-nullable context. We need to have nullable annotations enabled, otherwise the question mark doesn't work. So I can't annotate it. Now this is oblivious. So we really have three states. Oblivious. That means we don't know if the feature is not enabled, or this code was compiled with C# 7.3, where this feature didn't even exist in the first place. It's annotated. It's not annotated. That means not nullable. Or it's annotated. That means nullable, and annotated means we have a question mark placed. In some languages, the not annotated portion is represented with an exclamation mark, meaning not nullable. It depends. And then there is some numbers assigned. So whenever you see something with nullable, 0 means oblivious, 1 means not annotated, like this string here, so it's not nullable, and 2 means it actually is annotated, so it is nullable. Now let's confirm, let's take a peek at, again, the lowered C# code. So we compile our C# code and then decompile it, and now we see what the compiler does under the hood, and it's actually emitting nullable context and nullable attributes. Now these attributes live in the system.runtime.compiler services namespace. You cannot use them in your C# code. They are invalid in C#, but they are valid in IL code. And when you consume a project that now has these nullable annotations, the compiler can read them. But in your C# code, you can't write them. You write them with question mark or not putting a question mark. And let's see if these attributes are actually what we described earlier. So we have a question mark here, and we have nullable context of 2 here. That means it is annotated. So we really have a string question mark here, and it's matching our C# signature. What about method 2? Now we see there is this nullable context attribute. That's a bit of an overarching thing and now applies to all the children. Now this parameter doesn't have the attribute. If this parameter doesn't have the attribute, it now takes a look at the parent, which in this case is the method, the containing method of this parameter, which has the nullable context attribute. 1 means not annotated, so not nullable, and indeed it matches our C# code. Now here we override the nullable context from the parent. It's a kind of a closest win scenario logic. Now this nullable 2 says it is annotated, and this is where the question mark is coming from, overriding the nullable context that says not nullable. Now you may be asking, why do we have this hierarchy? Why not just put an attribute here and an attribute here and an attribute here? Well, it depends on the structure of your code. We would add an attribute pretty much everywhere, and this could bloat the IL, and hence it would bloat the size of DLLs and NuGet packages. So this is why there is this hierarchical structure. We can set some default that applies to the entire tree and then override it, so the compiler does a lot of optimizations. Now, if you were to read this yourself in your IL-based tool, that's quite complex. I'll show you in just a minute an example of a type that is alleviating this for us. Before, let's take a look at generics and also arrays. Because when it comes to arrays, or for example, the similar example would be a list of strings, we actually have 2 kinds of nullable. It's the list itself, or in this case, the array that could be nullable, and its elements of the array that can or cannot be nullable. And when we have no question mark, that means both the actual array, but also the strings in that array are not nullable. So we can safely dereference. Oops, excuse me, I was used to a Mac. We can safely dereference the array and also, let's say, the first element, and don't get any warning because neither the array nor its elements are null annotated. Now, when we put a question mark at the end, that means the array is nullable, but each element of the array are not. Let's replace it with second. We get a warning here because the array itself may be null. But we don't get a warning here because the elements are not nullable. That's now where the third argument coming in, the other way around. We don't have a question mark here, so the array is not nullable, but the elements are. So we have a non-nullable array with nullable strings. If we replace this with third, we see that we get a warning. We don't get a warning here. It's safe to index it, but accessing the length of it is not. And when we have fourth, now we actually have 2 nullable problems here, because not only is the array nullable, but also each of its elements is nullable. And hence we have 2 question marks. We have a nullable array with nullable strings. And the same really applies, for example, for a list as well. We could have a list that may contain nullable strings, but the list itself may also be null. And again, now we have two kinds of question marks. With dictionaries or those generics of higher generic arity, now we would get a lot of these attributes. And this is why this optimization is coming in. Tools like system.text.json is using this information, if you enable it, is using this information to determine whether something is null and not null, and then helps with deserializing or potentially throwing errors because we try to deserialize a null into something that was not annotated to null. But how do these tools work at runtime? Well, there's also now compile time features like Gosling generators that do this at compile time already. But what about runtime? If we do this at runtime, we would need with reflection to inspect this kind of, messy. We see for arrays, it kind of looks like this, because with an array, our third array is, the array is not nullable, but each elements are. So we have actually this nullable where the array is not annotated, but the elements are. And this gets really, really messy. And therefore, the .NET team has introduced a type that helps with that significantly. The nullability info context. Now let's jump into this example. I'm not going to inspect the entire code, but just the gist of it. We are using this type, the nullability info context, which helps us understanding what is and what is not null. Now getting further down the code of this, I'm inspecting, again, that's the same type that we took a look at, inspecting all the parameter infos. So we are reflection, getting all the parameters, and further down the road, now creating out of this nullability info context, a nullability info type. And this nullability info context is caching. So if I were to call this twice on the same parameter info, we would get a memoized result. So it's good for performance. You want to pay the price once, as long as we keep this context around. And then we can inspect this nullability info, for example, the read and the write state. When we have properties, we have a getter and a setter, and the getter and the setter may have different null annotations. We can also understand whether this is an array, and so on and so forth. And this is then what we could use this type for, to actually print this information or inspect this information at runtime ourselves. So I'm having now here the same example, the method where first is not nullable. And now when I run this example, I'm taking this class with reflection, inspecting all of its parameters, and then basically printing in kind of, in a different format, its nullable annotations. So we see the first is a nullable string. And indeed it is, where the second method has a non-nullable string and a nullable string. And there is a not null string and a nullable string, and so forth. For example, with an array, the third, where the array is not nullable, but its elements are, we get a not null array of nullable strings. And I think is Entity Framework using this as well? I'm not entirely certain, but you could also use in your tooling this type to understand with reflection whether there are or aren't nullable annotations. Speaking of tooling, you can also, since I mentioned Gosling already, we can also utilize this for compile time, because reflection works at runtime, Gosling is at compile time. Let's say we have, well, it's a bit of an older format, but let's say we have a data contract here that has specific data members, and the data member attribute has a required. And what I would like to do is writing a custom analyzer that warns us when we have a data member that is required, but actually declared it as nullable. So if it says is required, but make it nullable, we now get a warning. This warning is not emitted by Gosling. Well, it is, but it's not emitted by the compiler itself, but by a plugin for the compiler. Now warning me because I said it's required, but marked it as nullable. It kind of doesn't make, that's kind of a disjoint information. Likewise, if we say this member is required, but mark it as non-nullable, likewise again, we get a warning. And this is now working with a custom analyzer. We see analyzers work like you derive in Gosling from a specific type, you set a specific attribute, and then you can inspect the syntax tree. Not going into much detail, it's not a Gosling talk, but basically what we then trying to understand is we get those attributes, is our properties attributed via the data member attribute. And then we can, from all of the property symbols, this is how a property looks like in Wasslen or in the syntax tree. Or no, wait a minute, that's symbol. So this is how it looks in the compilation. We can understand whether it's with the nullable annotation, whether it's annotated or not. And again, it looks very similar as we saw before. 0 means no annotation. 1 means not annotated, so not nullable. 2 means annotated, therefore nullable. It's always the same kind of pair, 0, 1, and 2. And likewise, we can also write a fixer for that. So I'm getting not only a warning, I'm now getting a fixer. I can do Alt-Enter or Control-Dot, depending on the tool that you're using, and now using a so-called code fixer to automatically fix your code. That's all Wasslen. And when I apply this, now it adds the question mark again. And similarly, this is a custom code fix provider that now basically understands the syntax tree and can do this nullable type for us. If we take a peek at the syntax tree, Rider can do this, but there's also other tools. Visual Studio can do this as well. We can take a peek at the actual syntax tree. And if we dive into our type here, we find some property declarations. And these property declarations now here have the nullable type. And this now says that this property actually has a nullable type of, well, now a predefined type, which is the string. So when we take a look at the Wasslen syntax tree of our custom tooling, we can understand whether something is null or not null. So with reflection at runtime, with Wasslen at compile time. And if you would like to know more about Wasslen and how can you write analyzers and fixes, you can go to Shahab's blog. There is an amazing series on how analyzers work. So you learn how to write your own analyzers, but also how to write your own code fixes, and also when to and how to suppress all of these. All right. Now we talked a lot about the nullability and the flow analysis. And also we did checked what a real null check is and what a not real null check is. Just want to show one more thing about null checks, because there is more ways you can check for null. You can, what we saw earlier with the equality operator, or the is null and is not null pattern matching keywords, but you can also use, well, reference equality comparers that help you check if something is null or not. And there is also some more elaborate syntax, like, let me jump to the benchmarks. So this is the not null benchmarks check, what I showed earlier. And this is all the ways we can check if something is not null. If something is null, we can use the equality operator. We can use equals. We can use equals from object, which does a reference check. We can explicitly do a reference equals, where regardless of whether type implements equality or not, it's the reference that is checked for equality. We can use equality comparers, reference equality comparers. This is the trick that I showed earlier, where we upcast something to object and now have a pure null check regardless of whether the operator is overloaded or not. And of course, the pattern matching. And when it comes to not null checks, there is a very similar story, but we can also write something like, if we say something is of object or something is of a specific type, this also includes a null check. We can write this is empty property markers, which now also says, is this something? So is this not null? And of course, the most modern version, I think it was C# 9 or 10, something, just writing is not null, and it's almost plain. Well, it's actually quite plain English. Now, I mentioned arrays earlier and also lists. When it comes to generics, there is a bit of an intricacy when it comes to null, because of, again, the vast difference between nullable reference types and nullable value types. Let's say I have a list of int. And let's say I have a list of string. Now, what a list of int really is, it's a list of nullable of int. Actually, let me add the question mark. Again, what we see when the difference between a nullable list and a non-nullable list, at one time, there is none. It's just those additional attributes that get added for the annotations and warnings that get emitted if we don't check for null. But when it comes to nullable reference types, it's a totally different type. So what about lists? Now, list is unconstrained. How can we control the nullability and whether it has to be a class? And what about a nullable value type that is a different type, but a nullable reference type that is not a different type, just as additional attributes, a different runtime behavior? How can we deal with that with generics? Let's take a look at it. Now here, we just have an unconstrained generic. There's absolutely no constraints, so we can do whatever we want. We can say nullable value type. We can say not nullable value type. Well, of course, I can't pass null now. I need to pass something. We can say not nullable string. So if we were to pass null to this method, of course, we get a warning because this method is now t. I can also say nullable string. Not a warning here, of course, goes away. So we can use anything. It's unconstrained. What if we want to say that this method should only accept not nullable types, both not nullable reference types and not nullable value types? We can use the not null constraint. We just say where t is not null. So we can now only use not nullable types. Here is the not null constraint. If I were to use a nullable integer, we get a warning. We violate the not null constraint. Likewise, if we say a string of nullable, again, the not null constraint is violated, so it must be a string, a not nullable string, or a not nullable value type. But we can also constrain even further. Now, there is a difference when we constrain for class. That means only allow reference types. In particular, not nullable reference types. Where when we have a question mark, this also allows, this allows non-nullable reference types, but also nullable reference types. But still no value types. Let's see this constraint in action. So we have the not null class. That means we can't use a value type. We only can use reference types. But we said class and not class question mark. This is constrained to class. So we can't use a string question mark here. We get a warning. But with the maybe null that is actually annotated with class question mark, we can actually say nullable reference type here without a warning. And this similar also works for interfaces. So we could say, for example, there's a difference between, let's say I want something that is idisposable or something that is idisposable question mark. Now here we don't allow nullable disposables, but here we do. And to round things off, there's also the struct constraint, which only allows value types. So if we were to try to pass in here a reference type, this would not work.
Cool. Stefan, while you're talking about like how to create classes and generics and things like that, there's a question from the audience, which I think makes sense when it comes to creating like classes and things. So if in my class I have a problem marked with a required keyword, how does that work? Is it similar or is it different?
It is it is totally unrelated, but it also rounds things off when it comes to nullable. Let's assume I have here this to-do data item. Now, this stems from an ASP.NET Core example. So this is very similar to when you do .NET New web app, very similar example, just enhanced it slightly to deal with nullability. Now, the required keyword, actually, I'll just remove this, copy this type so that we can mess with it. Let's say we have a required property and a not non-required property. Optional, I think, is a better word for it. Let's say we don't have a constructor either. Let's just have a class, just call it static, where we have just some consumer, static void method. And now how do we initialize this to-do data? Actually, let's make this optional really. Now the required keyword forces me to set it. So if I were to initialize a new, let's say to-do data equals new. Now this gives me a compiler error because not all required members are set. I must have an object initializer. Also, I marked it in it, so I can actually only do it in an object initializer, but required says it after exiting the constructor, required must be set. Okay, I set required. And now there is no more warning. Well, the optional, actually, I made a bit of a bad annotation here. I marked this as optional, but not saying it's nullable. So if I were to now say data.optional.length, I don't get a warning. But this will be null. I never said it. So of course I should mark this as nullable, and now I get the proper warning there. But to come back to the required, we see required must be set. But it doesn't really have anything to do with nullability, because I could say, hey, this required is nullable. So I am now allowing to set null to it. However, it must be set. If I'm removing it, we still get the warning saying that, hey, the required member required was not set in an object initializer. So it's two different features. One is about nullability, one is about requiring it to set. But I can combine it and say, hey, I'm actually allowing null to be set. It's about explicitness. I'm now explicitly setting to null. Well, if I annotate this as not nullable, now I get a warning here. Yes, you said it. The required member is set, so the required requirement of this type is fulfilled, but I am violating the nullable constraint. So let's set to something, and all is good again. So those are two different features, but they do play in nicely, because earlier, without the required, now let's say I have here the required string. Now from a producer side, I would need to add a constructor now to enforce that required is actually set. What I would need to do is to say, hey, have a constructor, pass in a string, and then set the required to that text to really enforce the caller that this required must be set. But without a constructor, or only with a default or a parameterless constructor, there was no way to force the producer of this type, or the consumer of this type, to actually initialize the required property. Now with required, I can. We get an error here, set it to something, and now depending on the nullable annotation, I can set it to null, or maybe not null. So two different features, but they can be combined.
So as a producer, I basically ask the consumer, you have to explicitly tell me what is the value for this at the construction. And it could be null if it's nullable. It could be not null if it's not nullable. Yeah.
Exactly.
Great.
And this, let's actually tie this to a demo. Let's bring what we had back earlier. Now, this is a little ASP.NET Core example where we do have a required string. Let's actually get rid of this. Well, I'm also using it when you have the required keyword and you do have a constructor that sets all the required members, then you also need to put the sets required members attribute on top. Because if I weren't, let's call this method just a consumer method, where we would now say new to-do data. And I'm passing here 1, 2, false. All is good, but without that attribute, we now again get the compiler error that the required member isn't set. What I would need to do is now also create an object initializer and set the title that I made required to something. Now, that's kind of weird because I now said it twice because the constructor sets the title here, but so the compiler doesn't do any required flow analysis. When we have the required keyword, we must set it in an object initializer. Unless the constructor that we are calling is annotated with the sets required members attribute. And now I'm promising the compiler when this constructor is invoked, all of the required members are set. But I could lie. What if I remove it? Well, I do get a nullable warning, but I don't get any error about the required not being set. So basically with this attribute, we are promising the compiler all the required members are set, but never lie to the compiler. Anyway, now with this example in place, let's assume we have here a little ASP.NET Core application. And I did two things. I not only said, respect these required constructor parameters, so required members must be set, but also respect the nullable notations. That means if I mark the property as not nullable, so no question mark, and in the JSON we set it to null, deserialization will fail. Now let's confirm that behavior. Let us run this example. ASP.NET Core application is firing up. There we go. And now let's, I have here a couple of endpoints. If we say get, but we never have added anything. So if I try to get the first item, but it's not found. We never really set it. Let's create an item. Let's create a to-do item. And if we remember with the to-do data, let's put them next to each other. The title is required. The message is not required and nullable, so we can set it to null. And the bool is not required, so we could also omit it. Let's just have like this because only the text is required. And let's run this. And I get a bad, because of the constructor, right? Let's also get rid of the constructor. Let's only have these annotations. And now I'm missing something, sorry. I guess I have some code in place that now stopped compiling. Anyway, let's come back to the sample. And let's violate something. Let's violate the required. If I were to remove now the required member, we get a bad request. Likewise, if I were to make the message not nullable, now this message is not required, but not nullable. If I run the app again, now I'm setting the message to null. This should result in a bad request. And indeed it does, because we set the message to null. And we said, hey, please respect the nullable attributes. We said it's not nullable. We set it to null. Bad request.
Great. We are more than an hour on this show. I don't know how much is left, Stefan. If there is any other questions from the audience, please feel free to drop them in the chat. And if not,
I believe we have 5-6 minutes of code left. Is that fine?
And then we wrap it up in 5 minutes.
That sounds amazing. Because when it comes to those question marks, we saw this is just attributes. But in some cases, we need a more fine-grained solution when it comes to these attributes. Let's assume we have here this not nullable text property. And I actually have a setter that allows it, if we pass in null, then we set the empty string. So the setter is ensuring that it never is null, and the getter then therefore never returns null. Also, the backing field never is null. But when we actually set null, the compiler doesn't do dynamic flow and understand, hey, if value comes in, it's actually set to something that is not null. So we need to help the compiler. We can, with additional attributes, for example, the allow null attribute. If we bring this attribute in, now the warnings disappear because this is a so-called precondition. So we allow null to be set, but promise that when it's get, never is null, and we don't get any warnings. Likewise, this also goes into the other direction with disallow null. So what if I actually have a nullable backing field, so text could be null, but I don't want to allow null to be set. Actually, if we set null, we get an argument null exception. But I don't get a warning here, but I would like to get a warning. So we can use the disallow null. This is now the opposite. Although the text is nullable, we say, don't set null, and we get the warning here. And there is a bunch of more attributes that help you to educate the compiler with more attributions. And let's also the things like the not null attribute, which is actually I'm implementing here the throw if null check that has been added in the argument NullException.throw if null. And this method is using exactly this not null attribution, which means although we have an example here that passes in a nullable message, we don't get a dereference warning here because we have the not null attribute. And this not null attribute says, if not null is passed, this method doesn't return. Stop the analysis because we will throw here. This ensures that afterwards we are not null. And there is a bunch more attributes. I just want to highlight one more. Let's say we have a constructor. And in this constructor, I call a method. And this method initializes the field. But we still get the warning that, hey, the non-nullable field value must be set to a non-nullable value in the constructor. But we're not doing it in the constructor directly, but we are a helper method that we call in the constructor. If we were to do this value up here, compiler is happy. Again, the compiler doesn't do deep analysis or dynamic analysis, only static analysis. So again, we can help the compiler with the member not null attribute and saying, if this method is called, the member value is not null. But again, we could lie to the compiler. If I remove the code actually setting it, we don't get any warning. So with these attributes, be very careful. Don't lie to the compiler. And there is a bunch of these attributes. I'm putting it in the chat, the link, so I could share them with the community that lists all of these additional attributes that help you to annotate your code that you may need for your libraries to be more expressive. Then one smaller topic before we jump to the Q&A section, to the end of the session, is how can we avoid null in the first place? Let's say I have a method that returns an IEnumerable. IEnumerable of int, get numbers. And yeah, but for some reason, I want to return null out of it. Now that would mean I would need to make this nullable, to make this nullable, but then the consumer side gets a bit messy because the consumer now, if they want to for each it, they can't just call get numbers because they don't get the null warning. Now they need to do some additional null checks. It gets a little bit messy. So what we could do is make this as not nullable, and then, well, not return null, but return some kind of null object. We could return an enumerable dot empty of int, which is a singleton. It's backed by an empty array, so we don't have any too much of additional allocations, and we can the consumption part is happy. So this goes into now the so-called null object types. No, not null object types. The null object pattern, which says avoid null, but still do nothing. Like this for each. If I do a console white line here, this would never be hit because we just have an empty enumerable. And we can also implement our own nullable types. Let's say I have a logger. I have a method that requires a logger, or a class that requires a logger for testing to be injected. But for my tests, I don't want to test logging. I don't want to do anything with logging. But still, I don't want to do null checks all over the place. So let me implement the null logger. And we implement now this interface and just ensure that we do nothing. So we implement the interface. The iLogger has, for example, the isEnabled method, and it just returns false. A null logger is not enabled. The log method does nothing. It's no op. The begin scope method returns an idisposable. So yet again, we need to return a null object. And we do that by now implementing a null disposable, where the dispose of this null disposable again does nothing. Whenever it comes to null objects, they pair nicely with the singleton pattern, because null objects, they don't have any state. We don't have any instance fields there, so nothing that changes. So we can always reuse the same instance. So we just create one instance, and we again are nice to performance. We avoid a couple of redundant allocations. And we now can avoid passing iLogger by null and checking them by null. We just pass in a null object that does nothing. And to round off the talk with the last portion, well, the title is actually null and void. I haven't really talked about void, so I just want to round things off with what really is void. Whenever we have void on a method or on a local function, it says that there is no return type. In some cases, when you do reflection emit, so when you emit your own IL code at runtime, you kind of need to specify, hey, this is the void return type. So the void type does exist. There is system.void. This is an empty struct. It does exist, but we cannot speak of it in C# code. It's not allowed in C# usage. What we need to use is void. But for example, with reflection, we spoke of methods earlier, and of records. And with every record, we also get a deconstruct method. And the deconstruct method, when we hover it, we see this is void. Now, how can we write a test that ensures that this return type really is void? We reflection get the method info. We do get the return type of this deconstruct method, and we can assert it to be void. Well, we cannot write system.void. This is not possible, but we can say type of void, which is now basically referring to system.void. And this is how we can reflection, but also reflection emit, either test or emit void as a return type. And if we run this test, well, we run all the tests earlier, only the false one with the false null check was failing. This test is passing. And I guess this talk now ending with void. So this talk was not null and void, but it was null and void, because usually I lead with void and then it's void and null, but this is not so catchy.
Yeah. I don't have any more questions in the chat. I think it makes your job at the end easier, because there was just one question.
To select the winner of the 50% voucher?
So I hope I'm not butchering his or her name. It's Prasad Kumar. Please write to us over LinkedIn or send an email to us, and then you will get the voucher back.
Congratulations, Prasad.
Yeah, amazing. Then just to not forgetting about the important stuff, for the next week, we are going to talk about taming mutable state, which is applying functional programming in an object-oriented language. And Rodney Littles Jr. will be our speaker. Again, also an amazing speaker and a knowledgeable person. So please don't forget to subscribe to that talk, and see you. There's one thing in the comment. Yeah. And next week.
I have the feeling that with functional programming, there's also null involved a little bit, isn't it? We need to avoid null to some degree, don't we?
I think we do, because of F#, and like all of them needs to be IL compatible with each other, I guess, and interoperability. But let's see. I know some functional stuff, and let's see what Rodney has for us next week.
I'm looking forward to this, and thank you so much for having me. This was amazing.
Yeah, it was a pleasure to have you here. Thanks again. Have a nice morning, evening, wherever you are, and see you next week.